In this video we're going to look at the steps involved in converting a conceptual data model or ER diagram into a set of relations. So we're going to be just introducing the logical database design, and then we're going to look at the steps involved in building and validating a logical data model. So as we said already, the purpose of this step is to create a set of relations based on your conceptual data model. And the logical design is the process of constructing a model of the data used in an enterprise based on a specific data model. So in our case, that's relational, but independent of any particular database management system we're going to use and other physical considerations, like what are we going to put in triggers, are we going to put in indexes, all of that. So at this stage, we're already concerned with getting your conceptual data model into a state ready to be implemented, then taken and implemented into a physical database. So in our case, we're going to create a set of relations. Logical design is semi-physical realization of the concepts. And why we say semi-physical is we're not concerned with the actual physical file that's in memory, but we're concerned with placing the data into relational tables that we will visualize as a physical organization of the data. So we're concerned with the logical structure. And so recall that a relational database is a two-dimensional table made up of tuples and attributes. And in a relational database, all attribute values must be simple, or you can't break them down any further, and the keys must be not null and unique. The process of converting a conceptual data model into a set of relations is called mapping. So recall the steps involved in complete database design methodology. So we looked at step 1 last week, where we were building a conceptual data model. So this week we're going to be looking at step 2, which is building and validating the logical data model. The remaining steps then are the physical database design and maintenance going further. So the steps involved then for building and validating a logical data model. So we're going to be concentrating on step 1, which is deriving the relations for the logical data model. And then in the later video, we will look at the remaining steps, which is validating the relations using normalization, validating the relations against the user transactions, defining integrity constraints for the relations, reviewing the logical data model with the user, merging logical data models into a global model if that's applicable, and then checking for future growth. So now we're going to look at the first step involved in building and validating our logical data model. So in this step, we create relations for the logical data model that will represent the entities, relationships and attributes that have been defined in our conceptual data model. So we're going to look at how we represent our entity types and how we represent our relationship types. So we're going to start off with our entity types. So for each of our entity types becomes a relation in the logical structure. So we create a relation that includes all of the simple single valued attributes of that entity. For composite attributes, we use only the constituent simple attributes. So if you have name made up of first name and last name, well then first name and last name go in as attributes, not name. We make the indicated primary key of the strong entity type the primary key of the relation, and if the entity type has multi-valued attributes, you leave those out for the moment. Okay, so just to recap, you take your entity type, that becomes a relation. The name of the entity type becomes the name of the relation. All of the attributes go in. Well, the simple single valued attributes go in. If you have composite attributes, you just use the simple attributes or the composite part or the constituent parts, and if it's multi-valued, you leave it out for the moment. So in our example now, we have a vet entity type, and it has simple attributes PPS. It has a composite attribute name made up of first name and last name, and then it has a simple attribute salary. And PPS, as you can see there, is the primary key. So in converting this, we'll have a vet relation. Then inside of the vet relation, then we'll have attributes PPS, first name, last name, and salary. And then underneath we write primary key PPS. So see here, the resulting relation is as follows. We have vet, and then in brackets we put the attributes, so PPS, comma, first name, comma, last name, comma, salary, and then primary key PPS. So the name of the entity type becomes the name of the relation. The composite attribute name is not included in the relation, only its constituent parts, and the primary key of the entity type is the primary key of the relation. Next, then we look at how we represent the relationships, and that's the association or the link between two or more entity types. So the relationship that an entity has with another entity is represented by the relationship by the foreign key. So what we're going to be doing going forward is we're going to represent a relationship using the primary key foreign key link. In deciding where to place your foreign key, as we saw earlier, we had branch and we had staff and we had branch number in their staff table. So how did we decide that? Why did we not put staff number into branch, for example? So how do you decide that? So in deciding where to post or place the foreign key attributes, we must first identify the parent and child entities involved in the relationship. The parent entity refers to the entity that posts a copy of its primary key into a table that represents the child entity to act as a foreign key. So as this will become more obvious as we move along, or more apparent. So depending on the cardinality of the relationship and subsequently participation, we consider how to represent the following relationships. So for binary relationships, we look at one-to-many, many-to-many, and one-to-one. So in the one-to-many and many-to-many relationships there, we're only looking at the cardinality. If we have a relationship that's one-to-one, well then participation comes into play. So we're going to start off with our one-to-many. So if we have a one-to-many relationship, the entity on the one side is designated as a parent and the entity on the many side is designated as the child. So to represent this relationship, we post a copy. When we say we post a copy, basically we take a duplicate of the primary key or copy it and put it into the other relation. Okay, we don't cut and paste it, we copy it. Okay, so we post a copy of the primary key attribute of the parent entity that's on the one side into the relation representing the child entity, and that's on the many side, and this will act as a foreign key. If the relationship has one or more attributes, they also are they also are posted. Okay, so these attributes follow the posting. So we look at an example now. So here we have a relationship between branch and staff, which we saw earlier, and branch has many staff and a staff will belong to one branch. So branch is on the one side, so that's the parent. Child is branch staff is on the many side, so that's the child. So therefore, when taking our attributes, so for branch we have branch number, street, city, state and zip code, we take its primary key, which is branch number, and we copy it into staff. So now staff has staff number, name, position, salary and branch number. The primary key of both is identified, so for branch it's branch number, for staff it's staff number, but now we have copied branch number from branch into staff, and we identified as being a foreign key. So we'll say foreign key branch number references the branch number within the branch table. So what that means is that when you're inserting records or updating records for staff, the branch number that is given to a particular staff member must equal the value of a branch number in the branch table, or else you can leave it as null if it's not mandatory. Excuse me. In the above example, branch number is added as an extra attribute in the staff relation. It is a foreign key, which means it draws its values from the branch number in the branch relation. So now we're going to look at an exercise. So we want to transform the following ER diagram into a set of relations. So we have course and we have student. So course will become a relation, student will become a relation, and we have a relationship between them, which is one to many, where a course will enroll many students and a student is enrolled on one course. So we want to the next page then and do it. So I'm going to open up my text here. Okay, so I'll put down, so first we'll start off with our entity type. So course becomes, the entity type course becomes a relation. So we have course, and into them we put course code, course title, course leader. Don't worry about the underlines at the moment, they'll go out once I come out of the text box. Duration and points. Okay, now I'm going to leave it open in case I do any posting. So we have course code, title, course leader, duration and points. Underneath it, then I'll write primary key, course code. So then we put down student, and into student then we put student ID. We put Now we come to a composite attribute name. So we don't put in the composite, we only put in its constituent parts, which is first name, Control Z. Then we put in county, we put in year, and we put in date of birth. Again, leave it open in case we do any posting, and then we have primary key, student ID. Okay, so now we have both of our entities represented as relations. But if we leave it at that, we'll have records about courses and we'll have records about students, but we won't know which courses a student is on, and we won't know if a course has many students or any students. So now we want to represent this relationship. It's a one-to-many, so course is on the one side, so that's the parent, student is on the many side, so that's the child. So we take a copy of course code and put it into student as a foreign key. So after date of birth, I'm going to put in course code, and you can rename it if you want to, or just leave it as it, leave it with the same name if you want. Okay, and then you designate it as so. So I'd say foreign key. So now you can close your entities, or your relations I should say. Okay, so now we come outside of it, so we have course. Now from that ER diagram, very simple ER diagram, we have two relations. We have course and we have student, and they're linked by the primary key, foreign key linked by posting a copy of the course code from the course table into the student in the student table. So course code there is a foreign key. So that's your link. So we will enroll students on course codes that exist in this particular table here. Okay, so that's one-to-many. So now we'll move on to many-to-many. When a relation is many-to-many, we cannot post from one side to the other because it's multi-valued attributes. So in the previous case where we had a course and student, we posted the course into the student because the student enrolls on one course. We couldn't post course student into course because the course will have many students, so therefore there will be many values for the student ID, so therefore it's a multi-valued attribute, and we're not going to allow that in our mapping. So we cannot post if it's a many side from the many side. So therefore in a many-to-many relationship we can't post from either side to the other. So therefore we create another relation to do that. So for a many-to-many, we create a relation to represent the relationship and include any attributes that are part of the relationship. We post a copy of the primary key attributes of the entities that participate in the relationship into the new relation to act as foreign keys. These foreign keys will also form the primary key of the new relation, possibly in combination with other attributes of the relationship. So we look at an example. So here we have video and actor, where a video can have many actors in it, and an actor can play a part in many videos. So that's a many-to-many. So therefore, in translating that ER diagram, we have a video relation. So for video, we have catalogue number, title, category, daily rental, price, director number, etc. In actor, then we have actor number and their actor name. And then to represent the relationship, we're calling it role. And we have catalogue number, which comes from the video relation. We have actor number, which comes from the actor relation. And we have the character then, which is the character they play. The primary key is a combination of catalogue number and actor number, and both of those then are foreign key values. So if it's a many-to-many relationship, you create a new relation. So in the above example, we created a new relation to represent the relationship. Attributes catalogue number, which is the primary key of video, and actor number, which is the primary key of actor, are two attributes of this new relation. Both attributes are foreign key values related back to their respective relations, i.e. catalogue number draws its value from catalogue number in the video relation, and actor number draws its value from the actor number in the actor relation. There will be a composite primary key in the new relation. The key will be catalogue number and actor number. So we look now at an exercise. So now again we have student, and a student studies many studies modules. So a student can study 6 and only 6 modules, and a module will be studied by 0 or more students. So the cardinality here is many to 6, which is essentially many to many. Okay, so we're going to translate this example now into a set of relations. So I'm going to again take out my text. So we'll just write down student. So again, the student entity type becomes a relation. So student ID, first name, again it's, you don't take the composite, you just take the simple attributes. Last name, county, year, and date of birth. Okay, primary key, student ID. And then we have module, module code, title, description, and credits. Primary key, module code. So now we have two relations, student and module, and the attributes of student are in the student relation and the attributes of module are in the module relation. So now as I said, we look at the relationship. It's a student will study 6 and say only 6 modules, and a module can be studied by many students. So that's a many to many. So therefore we cannot put student ID into module because that will become a multi-valued attribute. We can't put student module code into student because again that would be a multi-valued attribute because the student studies 6 modules. So what we need to do is create a new relation. So into this new relation then, so we call it studies, we put the primary keys of the entities involved in the relationship. So we put in student ID and okay, if there was any attributes there, we put those in as well. And then primary key, neither on their own would be unique because a student will study 6 modules, so the student will be in this relation 6 times, and a module could be in that relation 40 times because it's 40 students or more could be doing that module. So a combination is unique. So I'll just copy and paste those. And then both of them are foreign keys. So foreign key, student ID, references, student ID, and foreign key, module code, references, module code. So in this example here, we have student and module. So student becomes a relation, module becomes a relation, and because the relationship is many to many, we create a new relation to represent that relationship. So only into this relation will go records when a student participates in a module. Well, then a record is created in the studies relationship relation for that. Okay, so that's your many to many. So if it's many to many, you have to create a new relation. So you end up with, if it's a binary relationship, you end up with 3 relations, one for each of the participating entity types and one for the relationship type. One-to-one then, as we said earlier, in creating one-to-one relationships, they're not as common as one-to-many and many-to-many. And then when you have a one-to-one relationship, it's not sufficient on its own to determine what to do. What we'll do as well is look at the participation. So creating relations to represent one-to-one relationship is more complex as the cardinality is insufficient on its own. Instead, the participation constraints are used to decide whether it's best to represent a relationship by combining the entities or by posting or whatever. So consider the following. So mandatory participation on both sides of a one-to-one relationship, mandatory participation on one and optional on both. So the first one we're going to look at is if it's one-to-one and fully mandatory. So in this case, we're going to post a copy of the primary key from one side of the relationship to the other to act as a foreign key. Because it's one-to-one and it's fully mandatory, you can post from either side to the other. So I can put staff number into car as a foreign key, or I can put vehicle license number into staff as a foreign key. So option 1, in this case here, we're putting staff number into car as a foreign key. So you see there staff number in the car relation there as a foreign key. In this example, we post a copy of staff number into car relation as a foreign key, and I've just renamed the vehicle registration number there to reg number. In option 2, we're putting the reg number into staff as a foreign key. Okay, so there, if it's one-to-one fully mandatory, that's what you can do. Another option, but I haven't included it here, is you could merge the two of them together into the one relation. So in that case, then you'd have staff number, name, position, salary, registration number, make and model. So basically you'd be recording for every staff the car registration number, make and model of the car that they drive. Why that is not preferable is because basically you're holding two objects in the one relation. It's because you're holding information with staff and you're holding information with cars in the one relation. So it is preferable that you would keep them separate in their two different relations, so you're not mixing up the objects. Okay, so now if it's one-to-one and optional on the one side, here we can identify the parent and child entities using our participation constraints. So the entity with optional participation is designated as the parent, and the entity with mandatory participation is designated as the child. So if it's once you have a parent and child situation, you can take a copy of the primary key from the parent and put it into the child as a foreign key. And if the relationship has attributes, they are posted also. So in our example here, you'll see that a staff may or may not drive a car, and a car is driven by one member of staff. So in this instance, staff is optional. So staff is the parent. So therefore, staff number goes into car as a foreign key. So staff number, name, position and salary. In car, then we have reg number, make, model and staff number, and that is a foreign key. So in this example, we post a copy of staff number into the car relation as a foreign key because the participation of staff is in the relationship is optional. So remember, when you're reading a relationship or reading it like this, a staff member will use 0 or 1 car. So therefore, they may or may not use a car, so therefore it's optional. And a car is driven by one and only one staff member, so the minimum is 1, so therefore it's mandatory. Okay. And lastly then we have if it's optional on both sides. So in that case you post from one side of the relationship to the other again, and since both sides are optional, you look at the data and you post from the side that's most optional participation to the other. So in this example, continue with our car and our staff. A staff member may or may not drive a car, and a car may or may not be driven by a staff member. So you look at the data and you'll see, you know, how many staff members you have, how many cars you have, and which of them then is most optional. So in that case, you would think that there would be a lot more staff members than cars, so therefore staff would be most optional. Assuming most of the cars are allocated and only a minority of staff use a car, we will post staff number, so we'll designate that as the parent. So we'll propose that staff number would be copied into car as a foreign key. Okay, so now we're going to look at an exercise here. So we're going to transform the following ER diagram into a set of relations. So we have citizen and passport. So, you know, as also citizens of the state, we may or may not hold a passport. So for every citizen, we're recording their PPS, their name, their date of birth and their country. And for every passport, then there's a passport ID and an expiry date. So the citizen may or may not hold a passport, but a passport has to be held by every citizen. So again, draw this out. So we'll put down citizen. PPS. Name is composite, so we just put in a constituent part, so first name, last name, date of birth, and country. And then primary key, PPS. And then we have passport, and we have passport ID, and expiry date. And primary key, passport ID. Okay, so there's both our entity types are represented as relationships. As relations. And the primary key of both entity types are the primary keys of the respective relations. So now we look at the relationship. It's one-to-one and it's optional on one side. So reading it, as we see, a citizen holds 0 or 1 passports, so they may or may not hold a passport, so therefore they're optional, and a passport is held by one and only one citizen, so the minimum is 1, so therefore the participation of passport is mandatory in this relationship. So citizen is optional, so therefore PPS goes into passport as a foreign key. So here then I'll do comma PPS, and primary key, foreign key, references, citizen, PPS. Okay, so citizen, PPS, first name, last name, date of birth and country, and passport ID, expiry date, and PPS of the person who holds the passport. And that PPS can only be drawn from the citizen table. Okay, so that's our steps involved. So in the next video then we will look at translating the conceptual data model from week 1 into a set of relations. Okay, thank you.